All right, so up until now, I have been giving you the equations and you had been finding all of the zeros. We're now just going to do that backwards. A lot of mathematics is being able to do something forwards and then do it backwards, like you want to do something and then undo it. So this time you're going to be given the zeros and you'll write the equation, but the same rule still applies. So for example, if I give you 3 zeros, what should the highest power in your equation be? 3. If I give you 4 zeros, the highest power in your equation should be 4. So like you can make sure that it matches. All right, now the zeros are irrational or complex. Let's talk about what those words mean. Irrational means it's not a pretty number. It's a decimal that keeps going and going and going. That's when you get like plus and minus square root of 7. Do you get what I'm saying? Like if you were to type square root of 7 in a calculator, it would be some mess. And then what does complex mean? What does that word mean? Usually if I wait long enough, someone remembers. Is it fancy? If you square root a negative, what do you get? It means it's going to be imaginary, okay? So if your zeros are irrational or complex, basically if they have a plus minus square root in them, then they happen in pairs. So what's called conjugate pairs. So for example, if I give you a 0, or if, I guess I'll write the factor that is x minus square root of 2. Even if it doesn't say it in the problem, you need to know that there is also an x plus square root of 2, and it happens from the plus minus that's there. And I'll sit so you guys can see past me. So it's from the plus minus. So just to do another example, if you have x plus 3i, what's the other factor? Even if it doesn't say it in the problem, you have to know it's there. Be x minus 3i. Okay, so you have to know that they happen in pairs when they have the plus minus and like all the weirdness, basically all the weird ones. Okay, my pep talk for this is it's a little bit of writing, but it's not hard. If you know your multiplication tables, it's just a bunch of distributing. All right, so we're going to put f of x equals, and I recommend starting all the way over to the side because sometimes it can get kind of long. We're going to take those zeros and write the factors. So you're actually, let me start with these two. Leave like a little blank and I'll come back to that one. If your 0 is 6, you're going to have a factor of x minus 6 because 6 minus 6 gives you 0. It's always the opposite of what you got. For the negative 2, then what would it be? Yeah, x plus 2, good. And I left a little gap in the front. For 0, you can write x minus 0 if you want, but x minus 0 is just x. So I think it's simpler if you write it that way. In essence, that's what the content of the idea behind this is. Now we're just going to have fun distributing it all together. It's the tedious but not difficult thing, all right? So leave that x alone. We're going to multiply these together. X times x, x squared. We've done this before. The outsides give you 2x. The insides give you minus 6x. So together, it would be minus 4x, good. And then negative 6 times 2 is negative 12. And then your last step is you're going to distribute the x through there. So that'll give you x cubed minus 4x squared minus 12x. By the way, this is how I make up the problems that I give you. I decide what I want the answers to be, and I just distribute everything together, and then that's how I decide what the problem is. Okay. Now, did it make sense? We had 3 zeros, and do you see how the highest power is a 3? It should match. Okay, let's try it again. F of x equals, because we're writing an equation, for x minus a half. Now, I'm just going to write off to the side here. That would be x plus a half. But what could you distribute through there so that you don't end up with a fraction? Like what would cancel out a 1/2, I guess is what I'm asking. 2. So if we distribute a 2 into there, it would be 2x plus 1. And you just want to do that if you have a fraction so that you don't deal with distributing a fraction. All right, and then it says x equals 3, so that would be x minus 3. It says with a multiplicity of 2. So what that would mean, don't write this. It would mean that it would be squared, but instead of writing squared, what could it's a twin. So we're just going to write it twice. It's for coming with me on my vocabulary. I just call it a twin. And now we're just going to have fun distributing that all together. So just like on this first one, we had the x just kind of like wait patiently. This 2x plus 1 is going to just wait patiently. Like whatever the first one is, it just has to hold on a second. And then we're going to distribute all this together. So x times x squared. Outsides are minus 3x. Insides are minus 3x. That doesn't cancel. Minus 6x. And good, negative 3 times negative 3 is plus 9. Now, when you go to distribute these, this has 3 terms in it, so the outside-inside thing doesn't kind of work. What you're going to do is distribute the 2x through there, and then distribute the 1 through there. So it's going to be really long. You're going to have 6 things all strung together. Remember, it's tedious, but it's not really hard. If you can multiply numbers together, you're going to be fine. It's about staying organized, right? So if you distribute a 2x through here, that'll give you 2x cubed minus 12x squared plus 18x. Did everyone follow me on that? I took 2x, distributed it through here. Okay, I'm not hearing complaining, so I'm going to keep going. Then if you distribute a 1 through there, what's going to happen? Yeah, it's the same. So just plus x squared minus 6x plus 9. And your last step is to put the like terms together. So 2x cubed, that's not going to combine with anything. What is going to go together here, though? Like, when we combine it, what are we going to get? Good. So together, that'll be minus 11x squared. And then 18x minus 6x, 12x plus 9. Then check. We had 3 zeros. The multiplicity of 2 counts twice. Remember, twins are still 2 people. And then we had the negative a half. So since we have a total of 3, we had a degree of 3 there. I'm still hanging in? Okay. It's tedious. I told you it was tedious. It's not necessarily hard. Maybe I'll do 3 and I'll skip 4 because those are really like the same exact kind of question. I'll fill it in and post it on Schoology so you can check it. I'm not trying to torture you. You got to do enough practice, but I'm not trying to torture you. All right, what would the factor be for 4? Yeah, x minus 4. And then you would have x minus square root of 7, but good, you're going to have x plus square root of 7. Even though it doesn't say it in the problem, you have to know it's there. In essence, that's like the answer. You just have to multiply it all together. So the x minus 4 waits patiently. Just a little bit of writing. I'll just keep pep talking. Go team, go team. You can do it. Just keep going. Now, when you multiply these, it's kind of nice how it turns out. X times x is x squared. Now, follow me here. The outsides will give you plus x square root of 7. The insides will give you minus x square root of 7. So those, and that will happen every time you have those plus minus pairs. Those conjugate pairs, those will cancel. All right, so now we're just going to do negative square root of 7 times positive square root of 7. So first of all, a negative times a positive is negative. And do you guys know what will happen? Like if you have square root of 7 times square root of 7, it will be square root of 49, which is 7. The roots just cancel out. And then we're going to multiply all that together. So let's see what we get. X times x squared, x cubed. Now I'm going to do the insides first on this one because I like for the exponents to go in descending order. Technically, it doesn't matter, but is anyone else like really type A and you're like, no, it has to be in order? Like that's me. All right. It'll be minus 4x squared. And then the outsides will give you minus 7x. And then negative 4 times negative 7 is plus 28. Good. No, number 4 is the exact same kind of thing, just with different numbers in it. So I'll fill that one out when I take a picture. This I'll post it to Schoology if you want to do that one for an extra practice one. But I'll leave that for now because I'm not trying to torture you. All right, so let's come down to number 5. F of x equals, what would be your factor for negative 1? Get x plus 1. Oh, and it says with a multiplicity of 2. So you can write squared, but I'd almost just recommend writing it a second time. So you just write it twice. All right, and then 3i. So you would have x minus 3i. Ooh, but then you would also have x plus 3i. So what I do when there's 4 of them. Oh, and do you see how since there's 4 of them, we're going to end up with an x to the 4th in our answer? When there's 4 of them, what I'll usually do is I'll multiply these 2 together, and then I'll multiply these 2 together. So they can go in pairs kind of like that. All right, so let's see what that gives us. X times x is x squared. The outsides are 1x, the insides are 1x. So together, 2x, 1 times 1 is 1. And then when you do these ones, x times x is x squared. The outsides and the insides cancel, which is great. Now, I usually just write this off to the side. When you do negative 3i times positive 3i, that's going to give you negative 9. And then I times I is I squared. I'm going to pause on this problem for a second. We're just going to talk about I squared really quick. Do you remember what just I is? It's a square root of negative 1. So if you square that, you just get negative 1. So I squared is negative 1. So what you end up with is negative 9 times negative 1, which is just 9. So it'll just be a positive 9. And let me make a suggestion. Up at the top, like next to your name or wherever, maybe just write that I squared equals negative 1 and like put some stars or something. I squared is negative 1. So your negatives are just going to cancel. All right, and then we're going to multiply this all together, guys. I know you're excited. So what I do whenever there's, see how this one's 3 terms, trinomial, and then this one's 2? What I'll do is I'll take this x squared and distribute it to everything. And then I'll take the 9 and distribute it to everything. All right, so that would give us x to the 4th plus 2x cubed plus x squared. I just distributed that x squared through there. And then I'll ask you guys this one just to keep you awake. Hey guys, when you distribute the 9, what are you going to get? Good. See, it's not hard. It's just a little bit of writing. You have to have some perseverance. Okay. And then what are the only 2 things that will go together there? There's not much. Yeah, x squared and 9x squared will be 10x squared. Since that's the only thing that combines, if you want to just erase that and write plus 10x squared so you don't have to recopy the whole thing, I'm fine with that. Or if you're like, no, I want to recopy the whole thing, whatever is your preference. I do get that it's a lot of writing. Okay. We'll do 6 and 7, and then I'll give you your halfway break. Okay. I do want to do both of these though, because they are different. I skipped 4 because it's kind of the exact same as number 3, just with different numbers, but all these are a little bit different. All right, so square root of 3. You're going to have x minus square root of 3. Good, and x plus square root of 3. And then what else are we going to have? Perfect. And we should end up with a power of what in our answer? The highest one. The highest one should be 4. So whenever there's 4 of them, I usually do the first 2 and then do the second 2. You can kind of group them together. And this one looks scary, but it actually won't be too bad because there's going to be a lot of canceling here. From this first one, you're going to get x squared. Outsides and insides cancel. Negative square root of 3 times positive square root of 3. Well, first of all, a negative times a positive is negative. Square root of 3 times square root of 3. Yeah, it's just 3. So yeah, minus 3. And then when you do these ones, you get x squared. Outsides and insides cancel. When you do negative 4i times positive 4i, and I'd usually just write it off to the side, it would be negative 16i squared. But remember what we talked about right here. What is that going to become? The I squared will be negative 1. So just plus 16. Good. And all of a sudden, it doesn't look so terrible anymore. It's way shorter. And then we're just going to multiply all those together. So x squared times x squared is x to the 4th The outsides give you 16x squared. The insides give you minus 3x squared. So since those are the same, we can actually put them together. What would that give us? Good, 13x squared. And then negative 3 times 16, minus 48. Yes, so actually we don't have a cubed and we don't have a regular x. And that's because the outsides and insides canceling, which is kind of nice because it makes the problem shorter. As a heads up, the same thing's going to happen in this one. This one looks kind of scary, but it's not going to be too bad because everything's imaginary. So f of x equals, and what are our factors going to be? Yep. X minus 7i, x plus 7i, and then, yep. So again, it's not hard, it's just a little bit of writing. And so when there's 4 of them, my suggestion is do the first 2 and do the second 2. I see, like, and then I love when this happens. We get to this part in the block where no one's looking at me anymore. You're all just doing the problem, which is great. Just make sure you check your answer. This would give you x squared. And again, I usually just write these off to the side. Sometimes people get to a point where they just do it in their head. It would give you negative 49i squared, which would turn into plus 49. Good. And then this one would give you x squared, and it would be minus 4i squared. 2 times 2 is 4. And then that'll turn into a plus 4. Yeah, just 4. And then we're going to multiply all that together. So it'll be x to the 4th, which is what we were expecting, plus, all right, outsides and insides together. Is that 53? X squared. And then 49 times 4. You could do 50 times 4 and then adjust it. Or do you guys remember how to actually multiply like numbers if you had to do a side problem here? Like 9 times 4 is what? 36. Do you guys remember how to do this from like whatever grade it was? And then 4 times 4 is 16. Plus 3 is 19, so 196. I mean, if you had to, you know, you got to get through that. But I think for that one, I would probably just do 50 times 4 is 200. Do you get what I'm saying? 50 times 4 is 200. And then just like adjust it back. You got to get through it somehow. So I'm just letting you know your options. Okay. All right. So for all of those that we did so far, did you notice how I kept the powers to either 3 or 4? Like, okay, so manageable, right? Now, if you go to look at this one, you're going to put your f of x equals 2 means your factor is going to be x minus 2, but it says with a multiplicity of 5. So it would be to the 5th. So hold on. That would be x minus 2 times x minus 2 times x minus 2 times x minus 2 times x minus 2. Do you get what I'm saying? Oh, so we're going to have a different method for how we get through that. Okay, so go ahead and flip over. The way you get through that is called the binomial theorem. The prefix bi means what? 2. Binomial, 2 terms. So it's 2 terms because it's x minus 2. If it was longer than that, you wouldn't be able to use this theorem, okay? It starts with Pascal's triangle. I'm going to write out the first couple lines and see if, usually people, I get at least 1 or 2 people that are like, oh, I've seen that before. So it starts out 1, 1, 1, and then 1, 2, 1. Hold on. I'm glad you know it. You might have. 1, 3, 3, 1. Well, my goal is to make you not hated. All right. And then it's 1, 4, 6, 4, 1. And usually at that point, I want to write out a couple more lines of it. How are we getting the numbers? You're adding the 2 above. So the next line would be 1. It always starts with 1. And then 1 plus 4, 5. All right, then what? 10, 10, 5, 1. Let's just write out one more line. It would be 1, 6, 15, 20, 15, 6, 1. Now listen. It's cool you guys know it and got excited about that. Listen, and it obviously would go on infinitely. This is called the 0th line. because anything in the world to the 0th power is 1. That is the 0th line. So this is line 1. This is line 2. Just look where I'm pointing. This is line 3, the one with the 3's in it. This is line 4, the one with the 4 in it. This is line 5, the one with the 5 in it. Do you see what I'm saying? So it matches up. All right. So when you go to expand these, when you do x plus 2 to the 4th, you're going to use the 4th line. And here, you know what? I'm going to pause a second and write that on the board so you can see it behind me, so I don't have to keep shifting the paper up and down. Okay, so here's what I want to have happen for the first one. I want you to set your pencil down and just watch. Because if you look away, do you know when you're trying to take notes and write at the same time? It's taking up 2 parts of your brain. I want you to just watch. Then I'll pause and let you copy it down. So you're going to go to the 4th line. I have it on the board behind me. So that's this one. The 1, 4, 6, 4, 1 are your coefficients. Don't pick up your pencil, just watch. So I'm going to write 1, 4, 6, 4, 1. You decide which line you're using. With me so far? Then you take whatever the first thing is to that power. So x to the 4th, and that's your countdown. So x to the 4th, then it's going to be x to the 3rd, x to the 2nd, x to the 1st, x to the nothing. I get that we usually don't write the 1s and 0s. I'm going to get to that in the next step. I suggest you write them though, because this is a pattern and it's part of the pattern. Then you take whatever the second thing is, in this case 2, and you do it backwards. It's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3rd, 2 to the 4th, and then just stick pluses in between them all. All right, so here's what happens when you go to simplify. Anything to the 0 power, you can just scribble out as though it's not there, okay? To the 0th power is just 1, just pretend it's not there. But you should still write it in the first step because it's part of the pattern and you don't lose track of what you're doing. All right, so what is this first term? Well, it's just x to the 4th. Okay, so that was not bad. Order of operations means you do exponents first, then multiply. So when you come over here, 2 to the 1st is 2 times 4 is 8. Good. So exponents first. 2 squared, 4 times 6, 24, x squared. Plus 2 cubed, 2 times 2 times 2, please don't say 6. 8, good. 8 times 4, 32x. You can drop that 1. Now 2 to the 4th, it's 2 times 2 times 2 times 2. Think before answering. Count on your fingers. It is 16. Very good. That's the answer. It's only ever 2 steps. Let's do one more where you watch first. I'll give you a chance to write it down. Just watch, all right? This says to the 3rd. Which line of the triangle are we using? The one with the 3's in it. Okay, so 1, 3, 3, 1. I'm going to write down 1, 3, 3, 1. You take whatever the first thing is, which is usually x, okay, to the 3rd. X to the 3rd, x to the 2nd, x to the 1, x to the 0. Write it. I know it's going to go away, but just write it. It's part of the pattern. Now, the second thing is a negative 4. So it's going to be negative 4 to the 0, negative 4 to the 1st, negative 4 to the 2nd, negative 4 to the 3rd, and then just stick pluses in between everything. All right, so anything that's to the 0 power, you can just scribble that out. I want you to still write it because it's part of the pattern, but those are gone. And then we're going to simplify this down. So x to the 3rd, and then here we're going to do exponents for first. Negative 4 to the 1st. That's just negative 4, right? Times 3, negative 12, x squared. Good. All right, here, negative 4 squared, 16 times 3 is 48x. And then negative 4 cubed. That is fair game without a calculator. You need to know some of your cubes for the smaller numbers. It is negative 64. And what do you notice happen? Positive, negative, positive, negative. That's what's going to happen when you have a subtraction, is they're going to flip-flop their signs. Positive, negative, positive, negative. So, and now that we did 2 of them, did you do this last year? The whole thing, the I'm seeing some yeses and some nos. Okay.
Yeah, we didn't do the try.
Okay, then never mind. Okay, cool. So do you see how this is to the third? Which line are you going to use? The third one, the one with the threes. Okay, 1, 3, 3, 1. Now the first thing is 3x, not just x. So you're going to need some parentheses there. It's going to be 3x to the third, 3x to the second, 3x to the first, 3x to the nothing. The numbers might get a little big in this one. We'll see what happens. Well, that might not be too bad. All right, and then the second thing is 4. So it's going to be 4 to the 0, 4 to the 1, 4 to the 2, 4 to the 3. Put pluses in between everything. Yeah, I may reach for a calculator at some point on this one because these numbers might get a little bit big. Or maybe not. We'll see. Maybe I'll do a little side problem. We'll do some multiplication. All right, scribble out anything to the 0. Now for this first part, you have to cube the whole thing. So it's 3 cubed and x cubed. 3 cubed is fair game without a calculator. That one you need to know. Good. So 27x cubed. Exponents first. 4 to the first is just 4. I'm actually just going to write that right above there. Now watch me point to this. You have to do 3 squared. 9, I'm just going to write that right above there, put a little dot, and then you have that 3 out front. So it's 3 times 9 times 4. I would, in my head, if I didn't have a calculator, I would do 3 times 4 is 12. 12 times 9 is 108. So 108x squared. There, see, we made it through without a calculator. We did it. I'm not sure about this next one. We'll see what happens. All right, exponents first. 4 squared, 16. 3 to the first is just 3, and then times 3. So if I had to get through that without a calculator, 3 times 3 is 9. And then off to the side, we could do 16 times 9. If I made you do it, you could do it, right? Like 9 times 6 is 54. That would be 9 plus 5 is 14, 144. Did you get it? Nice. All right, and then 4 cubed, 64. There, I didn't have to reach for the calculator. We made it through. Will you survive 2 more of them? You'll be fine. I want to do enough practice of it before I set you loose to do it on your own. You know what I'm saying? All right, which line of the triangle are we using? The one with the 4s in it. 1, 4, 6, 4, 1. So the first thing is 2x. You're going to need some parentheses. 2x to the 4th, 2x to the 3rd, 2x to the 2nd. I'm going to stop saying it because that's annoying. And then the second thing is a -1. So you're going to have -1 to the 0, -1 to the first, -1 to the second. And then put pluses in between everything. Sorry, that one got a little long. I'm trying to make it all fit on the screen there for you. Scribble out anything to the 0 power. And we're going to go term by term and see what we get. You have to take both the 2 and the x to the 4th. So what would that give you? 2 to the 4th and x to the 4th. Ooh, you kind of overshot it a little bit. 16. I think you just went like a little bit far. 16x to the 4th. It's 2 times 2 times 2 times 2. I would count on my fingers. That's how I would do it. All right, now for this one, exponents first. 2 to the 3rd. 8 times 4 is 32, but it will be negative. So minus 32x cubed. All right, for this one, 2 squared 4 times 6, 24. But what happens with this? Turns good. So plus 24x squared. And do you get that the terms are going to alternate? It's going to be plus minus, plus minus. All right, so this one will be a negative. Negative 1 cubed will give you a negative. 2 to the first is just 2 times 4 is 8. So just 8x. And then the last one's kind of interesting. Negative 1 to the fourth is just 1. So just plus 1. It's negative 1 times negative 1 times negative 1 times negative 1. This last one has a y in it. That actually means there's less math because it's not a number. So it's actually a good thing. Okay. Which line of the triangle are we using? 5. All right. 1, 5, 10, 10, 5, 1. I have to zoom out to be able to see the whole thing. All right. The first thing is 2x. So you're going to have 2x to the 5th, 2x to the 4th, and so on. And then the other thing is y. So you're going to have y to the 0, y to the 1, y to the 2nd, and so on. Oh, I barely made it fit. And then put pluses in between everything. Now again, simplifying this down actually won't be too terrible because y is not a number. So there's like less arithmetic to do there. Scribble out anything that's to the 0. Now for here, you have to do 2 to the 5th. Let's count on our fingers. Ready? 2, 4, 8, 16, 32. You just keep doubling. So it's 32x to the 5th. I'm going to say that again if anybody missed it. 2, and you just keep doubling. 4, 8, 16, 32. For the sake of keeping on going, what would 2 to the 6th be? After 32, you would get 64, 128. Like, yeah. I mean, I wouldn't ask you further than that. I'm just saying in general, that's how that would go. All right. You have to do the exponent first, then multiply. 2 to the 4th is 16 times 5. Ooh, close. 80. So you get 80x to the 4th times y. You can drop the 1, or you can write the 1 if you want to. All right, 2 to the 3rd is 8 times 10 is 80. So 80x cubed y squared plus 2 squared. 4 times 10, 40, x squared y to the 3rd. What's the next one? Some of you have stopped writing, so I know you did it ahead of me. I know you are. 10. It's 2 to the 1st is 2 times 5 is 10. X, y to the 4th. And then that last term is just y to the 5th.